We live in what should be the golden age of software development. Our IDEs predict our next moves, our frameworks handle the heavy lifting, and AI generates entire modules in seconds. Yet, ask any senior engineer and they'll tell you, programming still sucks. In fact, it might suck more than ever. The paradox is that as our tools get better at hiding complexity, our codebases become more fragile, bloated, and difficult to reason about. We've traded deep understanding for shallow velocity. Today, we're going to look at the programming still sucks reality, why better tools often lead to worse code, and how the abstractions we rely on might be the very things slowing us down. It's not that the tools are bad, it's that we've forgotten the cost of the magic they provide.
The primary way we manage complexity is through abstraction. We wrap difficult concepts in clean, easy-to-use boxes. But Joel Spolsky famously noted that all non-trivial abstractions are leaky. When your ORM generates a 12-way join that crashes your database, or your CSS framework requires 10 nested divs to center a button, the abstraction hasn't simplified the problem, it's just buried it. Modern tools encourage us to ignore the underlying mechanics. We treat our stocks like black boxes until they break. And when they do break, the distance between the developer and the actual machine is so vast that debugging becomes a process of trial and error rather than logical deduction. We aren't solving problems anymore, we're just massaging configurations until the errors go away.
In the past, you wrote code. Today, you assemble dependencies. A modern Hello World web application can pull in over 1,000 transitive dependencies before you've written a single line of business logic. This is the dependency spiral. We use a library to solve a small problem, which brings in 10 other libraries, each with their own vulnerabilities and maintenance overhead. We've reached a point where the majority of our codebases consist of code we didn't write, don't understand, and can't easily fix. This Lego brick approach to engineering makes us feel productive in the first hour, but it creates a maintenance nightmare in the 5th year. Every dependency is a debt that eventually comes due. Then there's the AI factor. Tools like Copilot and ChatGPT have drastically increased our output velocity, but velocity is not productivity. If an AI generates 100 lines of code that you only 80% understand, you've just created a net loss in maintainability. We are generating code faster than we can peer review it. We are prioritizing the write speed over the read speed, despite the fact that code is read 10 times more often than it is written. This leads to a copy-paste culture, where developers don't solve problems, they just prompt for solutions. The result is a codebase filled with subtle hallucinations and architectural inconsistencies that no human would have intentionally designed. Modern frameworks often demand a steep tax. We spend more time learning the idiosyncratic way a framework wants us to handle state or routing than we do learning the underlying language or the problem domain itself. This creates a generation of framework developers rather than software engineers. When the framework changes or falls out of fashion, the knowledge becomes obsolete. We've built our foundations on shifting sands. We choose the best tool for the job, but we forget that the best tool for the developer experience isn't always the best tool for the long-term stability of the system.
Think about the stack trace of a modern web error. It's no longer 5 or 10 lines of code you wrote. It's 50 lines of framework internals, middleware, and third-party wrappers. The distance between your code and the actual execution environment is growing. This makes it incredibly hard to develop a mental model of how your application actually works. When everything is auto-magical, nothing is predictable. We spend our days debugging the interactions between our tools rather than the logic of our applications. This is why programming still sucks. We are fighting the environment as much as we are fighting the problem.
So what is the alternative? It's not to go back to writing assembly on punch cards. It's to practice intentional tooling. This means choosing tools that prioritize transparency over magic. It means favoring libraries that do one thing well over frameworks that try to do everything. It means being willing to write a bit more code ourselves if it means we actually understand how it works. We need to stop chasing the latest developer experience trend and start valuing system maintainability. The best tool isn't the one that writes the code for you, it's the one that helps you think more clearly about the code you're writing. Programming will always be hard. It's the nature of translating human intent into machine logic. But we don't have to make it harder by layering on unnecessary complexity. The next time you reach for a new framework or an AI prompt, ask yourself, is this tool solving a problem, or is it just moving the complexity somewhere else? Better code comes from better thinking, not just better tools. Thanks for watching.